In this example, the topic is quadratic functions and it's a word problem. As sales manager for Montevideo Productions, you are planning to review the prices you charge clients for television advertisement development. You currently charge each client an hourly development fee of $2,500. With this pricing structure, the demand measured by the number of contracts Montevideo signs per month is 15 contracts. This is down 5 contracts from the figure last year when your company charged $2,000. So last year, when P1 was $2,000, it was 20 contracts because it's down 5. So Q1 would be 20 contracts. So let's write this down. So when P1 is $2,000, the quantity demanded, the number of contracts, is 20 contracts. And then when the price P1 was, when P2 is $2,500, Q2 is 15 contracts. Now we're supposed to find the demand equation. So like always, we start with the slope. The slope is Q2 minus Q1 over P2 minus P1, which is 15 minus 20 over 2,500 minus 2,000. Now if you divide these numbers, you're supposed to get negative 0.01. Now the demand equation is Q minus Q1 is equal M P minus P1. So we know the slope is negative 0.01. And then we take a point P1 is 2,000. So plug in 2,000 here, and then Q1 is 20, plug in here, and then solve for Q. This means that Q minus 20 is equal to negative 0.01p plus 20. Now I add 20 to both sides. I'm going to get Q equal negative 0.01p plus 40. So this is the demand equation. In other words, this is the price, the hourly development fee. This is the hourly development fee, and this is the number of contracts. For question B, on average, Montevideo bills for 50 hours of production time on each contract. Give a formula for the total revenue obtained by charging P dollar per hour. In other words, as a function of P dollar per hour. This can be confusing. It's usually the revenue. Usually we say revenue is equal PQ. But PQ will be the number of contracts, and P should be the price or the fee you charge per contract. That'd be okay. However, this time the P doesn't represent the fee per contract. The fee represents the charge per hour. So therefore, but they told us that they're charging 50 hours per contract. So each hour is P dollars. And then you need to multiply it by 50 because 50 times P. So the revenue is the number of contracts times the charge of each contract, which is 50 hours times the price, the fee per hour. So it's 50p times Q. Now we need to replace 50p. The Q, we know it's the quantity demanded, which is in function of the price. It's a negative 0.01p plus 40. Now all we need to do is distribute. If you distribute, you get Q equal negative 0.5 p squared plus 2000p. Now for C, the cost to month video productions are estimated as fixed costs 120,000, variable costs 80,000 per contract. So if we're trying to find the cost as a function of Q, that will be easy. That will be C is equal 80,000 per contract. So 80,000 times contract, which is Q, plus 120,000 fixed cost. Now for II, express the cost as a function of the production charge P. Now all we need to do is replace the Q, see 80,000 Q, but Q happens to be negative, the demand, negative 0.01 P plus 40. So the cost is, just multiply it, we get negative 800p plus 3,320,000. So that's the cost as a function of the hourly charge P. Now for the last one, express the month video production monthly profit as a function of the hourly development fee. So that one, and then the price to charge to maximize the profit. So first, the profit is equal revenue minus cost. We already found the revenue and the cost. All we need to do is plug it in. So the revenue is negative 0.5 p squared plus 2000p minus, and we said the cost is minus 800p plus 3,320,000. Now if we distribute, we're supposed to get negative 0.5 p squared plus 2,800p minus 320,000. Now if we want to know the price to maximize the profit, that will be little p will be minus b over 2a, which is negative 2800. That's the b over 2 times negative 0.5. Forget the parentheses here. If you do that, you're supposed to get $2,800 per hour. $2,800 per hour to maximize your profit. And that's it for this problem.